Hello everyone, I'm about to do question 3 from the KZN Mathematics paper 2. Question 3, 4 and 5, they cover trigonometry. Okay, 3.1, I'm given a diagram below now, and I'm told that P is a point in the first quadrant such that 5 cos theta is equal to 3. Okay, immediately whenever they tell me this, I need to change it to cos theta is equal to 3 over 5. By doing this, now I'm giving myself the value of x and r. All I need to do is to find the value of y by using Pythagoras theorem. Then I can answer every question that follow. Okay, I know that x squared plus y squared is equal to r squared, right? This thing is 3 squared. I don't know the value of y. R is 5 squared, right? And then y will be equal to 5 squared, which is 25, minus 3 squared, which is 9. So 25 minus 9 is 16. The square root of 16 is 4. And then now I have a complete right angle triangle. I know I have 3 units here, 4 units there, and 5. I can answer every question that follows. Okay, another thing that I was told is that point R is on the second quadrant such that POR is 90 degrees. Okay, let's focus on the first thing, on the first statement, right? I'm asked to find tan theta. Please guys, before you just write tan theta, make sure that you've written this thing first, because there is a mark for that. Are you together? Now I know that tan theta will be just 4 over 3, because tan theta is equal to opposite over adjacent. They want me to find the value of sine 2 theta. I can expand my double angle as 2 sine theta cos theta. I know that sine theta is 4 over 5, cos theta is 3 over 5, and the 2 will give me 24 over 25. This is the value of sine 2 theta. Now they want me to find the value of k, right? K is a point, is an x value which is at the second quadrant, and I know that k has to be a negative value. Okay, so if I can create a right angle triangle here as well, are you together? Simply means I will have my vertical distance there to be 6. Please note, the angles on a straight line, they all add up to 180, right? If I have theta and 90 and another angle on the straight line, this thing simply means that the other angle on the straight line will be 90 minus theta, because they are angles or angles on a straight line. Whenever I add all these angles, I must get to 180. Are we together? So if this angle here is 90 plus theta, and here I have 90, it simply means that here I should have theta. Are we together? I should have theta there. Okay, what do I know now? Remember that initially I was told that cos theta is equal to 3 over 5. Né? But now for the new bigger triangle, I can say that cos theta is equal to x over our hypotenuse. Our hypotenuse is length OR. I have cos theta equal to something, cos theta equal to another thing. I can simply say, instead of using cos theta, because after using cos theta I need to go back and find the x value. Why can't I just use tan? I think it would be easy if I use tan. Remember that I said tan theta is equal to 4 over 3 out together, but right now tan theta will be equal to k over 6 out together. So all I'll have to do is to say k over 6 is equal to 4 over 3 out together. I can just cross multiply here. I'll have 3k equaling to 24. then k is equal to 8 8 plus, but guys, please note that I've just substituted k as a positive term. I know that k is an x value which is on the second quadrant. That means k should carry a negative value altogether. So it simply means that k is equal to a negative 8. Are we together, guys? This is one way of showing that k is equal to negative 8. This is the easier way. I could have shown it by the other way that I've just erased. Remember that cos theta is 3 over 5. Are you together? And for the bigger triangle, cos theta is equal to 6 over the length of OR. The length of OR is the hypotenuse of the circle, of the triangle. Please remember that. I have cos theta equal to something, cos theta equal to something. It simply means those two things are equal. Are we together? Therefore, I can say that OR is 10 units. Are we together? Simply means that the hypotenuse here is 10. And then I can find the value of k by using Pythagoras theorem. Let me continue writing on the other side. I'll simply say 10 squared is equal to 6 squared plus k squared. Are we together? So this k squared will be 10 squared minus 6 squared, which is 64. Then k is the then I'll put the square root on both sides here. Square root and square root. I'll have a plus minus 8. Since I know that k is on the left hand side of the y-axis, simply means that k is negative 8. It's up to you how you prefer to find the value of k, right? But k is a negative 8, right? Okay. 3.2, I'm supposed to simplify fully this trigonometric expression. May I please erase here, guys? You can just pause the video and then, or just take a screenshot, write down everything that you need to write, because I want to continue. Excuse me. Okay, I'm supposed to simplify what am I given? I'm given cos 385 degrees plus beta multiplied by sine 35 degrees minus beta plus sine 25 plus beta. It doesn't fit. Let me move to the left hand side. Excuse me, guys. Excuse me. Okay, please, guys, I'm supposed to simplify here, no? Please note that whenever I have angles which are above 360, I need to subtract 360 from those angles, right? So now I will have the cos of, whenever I subtract 360 from 385, I will be left with 25 degrees plus beta. All together. And then remember that I still have my sine 35 degrees minus beta. and I have my okay. Please note that, guys, here I'm supposed to simplify without the use of a calculator first, né? And already the on this side I have two different trig ratios. That means I must use the sine rule if I want to, né? Or it's fine. No, I can't use the sine rule. Rather, I wanted to say the compound angle for sine, but I can also use the one for cos. Let me just use the one for cos. I think it will be much more simpler. I'll have sine. I'll have sine 55 degrees plus beta. Please note, let me erase this part here, because initially I wanted to do the compound angle for cos, for sine rather, but let me just do it with cos. I can use my compound angles here, guys, né? Please note that if I have sine 30, sine 30 I know very well it will give me 1 over 2, né? But I can write sine 30 as cos 90 minus 30. Are you together? Why? Because cos and sine are co-functions of each other, and if the angles between them are equal to 90, therefore that means those two numbers are equal. Sine 30 will be equal to cos 60, because 90 minus 30 is cos 60, right? When I punch sine 30 on my calculator, I'll get a half, and I'll get a half for cos 60 as well. So by changing the trig ratio to its to its co-ratio and then writing 90 minus, we are basically not changing anything there. Are you together? So initially there, guys, I had sine 35 minus beta. If I can write a sine 90 degrees minus, that's 35 minus beta. There's nothing I have changed there. Are you together? This thing simply means that I'll have cos of 25 degrees plus beta multiplied by the cos of 90 minus 35 will give me 55 degrees. A negative times a negative will give me a positive beta, right? Then I have a plus sine 25 degrees plus beta multiplied by sine 55 degrees plus beta. I can just apply the compound angle for cos here, guys, because I have cos and cos multiplied, then I have sine and sine multiplied. I can see that the first angles are equal, the second angles are also equal. So I can simply say this is cos, the first angle is 25 plus beta, and then I have the second angle which is 55 plus beta. Are you together? So please remember that if I had a plus here, I need to have a minus in between the angles. Are you together? And my angles are 25 plus beta and then 55 plus beta, like that, né? This thing simply means I have the cos of the two betas will subtract one another, and then I'll have 25 minus 55, which is a negative 30 degrees. And then I'll have a negative 30 degrees is on the fourth quadrant where cos is positive. So I'll simply, I know that this thing will be just cos of 30 degrees, which will give me root 3 over 2. So cos of 30, this entire statement here, this entire statement is equal to root 3 all over 2. Are you together? And then now I'm supposed to prove the given identity there. Okay. For the given identity, let me erase this so that I can create my space to write. So that I can create my space to write. Okay. What I'm supposed to prove. Okay, I'm supposed to simplify sine 3 theta, ne? And all I want to do is to make sine 3 theta to be equal to this one. Okay, let me just do that. Sine 3 theta can be expressed as sine 2 theta plus theta, right? This will be sine 2 theta cos theta plus cos 2 theta sine theta. The double angle for sine, it will be just sine 2 sine theta cos theta. I still multiply this by cos theta, are together. But for the double angle for cos, since there, guys, I will have cos squared, that means I must change my double angle to the one that has cos squared, right? I'll simply say 2 cos squared theta minus 1. This thing will be multiplied by sine theta, right, together. Please note that for the first term, I will have 2 sine theta cos squared theta plus, whenever I multiply sine theta to this, I'll still have 2 sine theta cos squared theta, then I'll have a negative sine theta. These two things will add one another. I'll have 4 sine theta cos theta minus sine theta. So now I can see that my left hand side is also equal to 4 sine theta cos squared theta multiplied, minus sine theta. So my left hand side is equal to the right hand side. 3.3.2, they say hence or otherwise prove that prove the following identity. The following identity simply says I must just prove that this thing is equal to sine theta. How can I do that? There at the top, I know that sine 3 theta is equal to 4 sine theta cos squared theta minus sine theta, are together. But this thing was added to sine theta, are together. All over, I have a number added. So all I need to do is to change since I have a number added, all I need to do is to change my double angle to the one that has a number subtracted, are together. So simply means that at the top I'll be left with 4 sine theta cos squared theta. At the bottom I'll have 2 plus 4 cos squared theta minus 2, because the 2 will multiply here and there. At the top I'll have 4 sine theta cos squared theta. At the bottom, the 2's will subtract one another, guys. You can all see that we have a plus 2 and a minus 2, right? I'll be left with 4 cos squared theta. The cos squareds will cancel, the 4's will cancel. I'll be left with sine theta. Okay, whenever they say hence in mathematics, they mean that use what we've just calculated before, or in this case, use what you've just proven before. Are we together? Okay, that's how you do it. Please screenshot or pause the video, write everything down before I erase. Okay, now I'm supposed to determine the values of theta for which the identity in 3.3.2 will be undefined. The identity in 3.3.2 will be undefined if and only if the denominator is equal to 0. Are you together? So the denominator is, I'll just say 2 plus 2 equal to 0. This thing will be undefined when the denominator is equal to 0. Yeah? I'll just take my denominator to the, this 2 to the right hand side. I'll have 2 cos 2 theta is equal to negative 2. Then cos 2 theta is equal to negative 1 because I'll divide by 2 both sides. My reference angle is cos inverse 1, which will give me 0 degrees. Nah? But now I just need to, I don't have to be strict here, guys, no, because this is not general solution. Don't have to be strict. I'll simply say 2 theta is equal to 180 degrees. Just punch cos inverse negative 1, you'll get 180 degrees. Né? Therefore theta must not be equal to 90 degrees. Shimbu. If theta is 90 degrees, the entire identity will be undefined. Please pause the video and write everything down. Okay, now I'm asked to determine the minimum value. Okay, please note, guys, that I know for a fact that my cos graph will be always between -1 and 1. Are you together? Cos 3x is always between -1 and 1. But now I have a 5 subtracting the cos 3x. It simply means I need to subtract the 5 on the left hand side and also on the right hand side. Are you together? So I'll have cos 3x. If I have -5 there, that means remember that I had a -1 and a 1, and if I'm subtracting side in between, I must subtract 5 here and here as well. So this thing simply means that cos 3x minus 5 will be between a -6 and a -4. So that means -6 is my minimum value, -4 is my maximum value. So I was asked to find the minimum. Simply say minimum is -6. Okay, I'm in question 4 now. I'm told that in the diagram below, RT represents the height of a vertical tower, with T the foot of the tower. A and B represents 2 points which are equidistant from T. Okay, these two are equal. That's what I'm told. And which lie on the same horizontal plane as T. Okay, the height of the tower is H. The angle of depression of B is alpha. Whenever they give me the angle of depression, they also give me the angle of elevation, because the angles are depressed and elevated in at the same angle between parallel lines. Okay, okay, I'm told that the angle RBA is beta. I'm asked to determine angle ARB in terms of beta. Okay, please note that, guys, if AT and TP are equal and they are in the same horizontal node, this thing simply means that these two are also equal as well. So if angle RBA is beta, it simply means that RAB should be beta as well. Are you together? And then this guy over here will be 180 minus 2 beta. This guy will be 180 minus 2 beta. Okay, now I'm asked to prove that AB is equal to that. Where is AB? Oh, there is AB. For me to find AB, I must at least find the length of RB first, because I know that RB would be the same as RA. And then now I have RB and RA, and the angle in between is 180 minus 2B. I can just use my cosine rule. Okay. Firstly, let's find RB. I have a right angle triangle there, ne? I can simply say that sine of angle alpha is equal to H over RB. Are we together? That means the length of RB is H over the sine of angle alpha. Does it make sense? So if this guy is H over sine alpha, that means this one is also H over sine alpha. Are we together? So I can find the length of AB by just using the cosine rule. I know that AB squared is equal to AR squared plus BR squared minus 2AR times BR and the cos of ARB. Are we together? So AR is H over sine alpha plus H over sine alpha minus these two things are squared, ne? Minus 2 times H. I'm multiplying the same thing twice, so I'll just write squared there, ne? This is cos 180 minus 2 beta. Lack of so these two things they are the same, so I'll have 2 multiplied by H over sine alpha all squared minus 2, so it's plus now. Why am I saying it's plus? I'll share that in a minute. Cos 180 minus 2 beta is on the second quadrant, and on the second quadrant cos is negative, so I'll have a negative number times this negative. I'll get a positive. All together, so this is cos 2 beta. I can take out a common factor here, guys, ne? Actually, let me erase everything actually, because now this thing is clumsy. Use a different ink. I can take out a common factor here, guys, ne? I can take out H over sine alpha squared. Then I'll leave 2 plus 2 cos 2 beta. H over sine 2 plus cos 2 beta can be written as 2 cos squared beta minus 1, right? This is H over sine alpha all squared. I have a 2 plus 4 plus 4 cos squared beta minus 2, and then I will have h over sine alpha all squared. I'll be left with 4 cos squared beta here, guys, né? And this thing, remember that this thing is it was always equal to ab squared. Together, ab squared. So now if I can put square roots on both sides, I'll be left with ab is equal to, I'll have h over sine a multiplied by 2 cos beta, which is 2h cos beta over sine alpha. So now I've proven that AB is equal to that thing, nah? And then I'm supposed to calculate the height of the tower. I'm supposed to calculate h if AB is okay. Let me just do it. Remember that AB, even if guys you couldn't prove this thing, you must take these 3 marks, huh? AB is equal to 2h cos beta over sine alpha. They want me to find h, né? So this thing simply means that h will be, let me just substitute, not try to be fancy. AB it's 4.5 units, guys, né? 2, I don't know the value of h, but for now, I have cos beta is 65 degrees, and then I have sine alpha, which is 51 degrees. Simply means that h will be equal to, let me just punch my calculator, 4.5 multiplied by sine 51 degrees divided by 2, all divided by 2 multiplied by cos 65. H is 4.1. 4.12. H is 4.12 units, right? So that's how you would have tackled question 4. Question 5, okay. Question 5, I'm told that in the diagram below, g of x is equal to a sine x, and it is drawn for the interval of x is between negative 180 and 180. I'm told that a is equal to negative 90 and negative 2 are the coordinates of the turning point of the graph. Okay, find the value of a. Since I have the minimum value of negative 2, it simply means that my amplitude was 2. So a is equal to 2. On the same grid provided in the answer book, draw the graph of f of x. Okay. For me to draw the graph now, guys, I need to follow some steps. First, I must find my period. Period is 360 all over the coefficient of the variable there, né? So there's 1. So it simply means my period is 360. Then second, I must find my interval. Interval is always the period over 4. 360 over 4, I'll get 90. This thing simply means that in every after 90 degrees I'll get an important x value. It's either I'll find the x value at the turning point or the x value at the y-intercept. Not y-intercept, rather x-intercept, né? And then I'll go and use my unit circle. My unit circle is the one that will give me those x values. It's called a unit circle because the radius between the distance from the center to the circumference is 1. Okay, since, guys, my graph has been shifted 30 units to the right, it simply means that my graph will start at positive 30 degrees. 30 will be my starting point. Right, together, and then moving from 30, I just need to keep on adding the interval for me to find the important x values. Right, together. So 30 plus 90, I'll get a 120. 120 plus 90, I'll get a 210. Okay. And then to consider the negative angles, 30 minus 90, I'll get a negative 60. Negative 60 minus 90, I'll get a negative 150. The negative 150 minus 90 get a negative 240. Right, together. Okay, so whenever I'm at 30 degrees, since I'm drawing the graph, of course, whenever I'm at 30 degrees, I need to find out what is the value of x. My value of x will be 1 when I look at my unit circle. I'll take that 1 multiplied by the 2 in front. What will I get? I'll get a 2 there. Are we together? Whenever I'm at 120 degrees, what is the value of x? My value of x will be 0. When I'm at 210, the value of x would have been negative 1 times 2, which is negative 2. So my graph would have been here. Okay, when I'm at negative 60, the value of x is 0. When I'm at negative 150, my graph will be here. And then 240, it would have been here. And then all I need to do, guys, is to just join these lines, né? My graph would have been like this, né? But since it is restricted, it will be like this. But please, guys, make sure that your drawings are more smoother than mine. I'm not good in drawing, but my graph should have gone like this. Okay. Now I'm asked to find the range of f of x. My graph is between, I'll simply say y is an element between negative 2 and 2, because 2 is my amplitude, right? I'm supposed to find the period of g of 3x. Simply means whenever I see x, I need to put 3x there, né? So my period will be equal to 360 divided by 3, which is 120 degrees. Determine algebraically x, they want me to find the point of intersection of the two graphs. I must find this x value and this one. Are you together? For me to find point of intersection, I must find the general solution. How can I do that? Let me erase. Will I even need that space? Okay, maybe I will. Let me write in blue. They said f of x is equal to g of x, right? F of x, I said it's 2 sine x. This thing will be equal to, no, that's g of x rather. G of x is 2 sine x, and then this thing will be equal to f of x is 2 cos x minus 30 degrees. I'm supposed to solve x here. Now guys, I can divide both sides by 2. I'll have cos x minus 30 is equal to sine x, right? I need to solve x here, guys. Now, so I'll simply say cos x minus 30 degrees is equal to, I can change into 1 trig ratio. Cos sine x is the same as cos 90 minus x. I'm solving for x and the trig ratios are the same. Simply means that my angles should be equal, right? So I can simply say x, since guys I'm not finding general solution, I won't be too strict on myself. Né? X is just equal to plus or minus -90 minus x. Now together simply means that x minus 30 degrees is equal to negative -90 minus x, or x minus 30 degrees is equal to 90 minus x. So here there's no solution, and then for this one I'll just say 2x is equal to 120 degrees plus k 360. Okay, then x is 60 plus k 180. Alright, together. So this point here, these two graphs should have met when x is 60, and then here they should have met when x is 120, negative 120 rather. How do I know that? I'll just keep on substituting the values of k as integers. When I put 0, I'll get 60 degrees together. So now I know that x will be 60 degrees. Another one, whenever I put a -1 there, I'll find my x value to be a negative 120 degrees together. So now I'm asked, determine the values of x for in the interval, okay, for which the graph of g is equal to 0. Not graph of g, but the gradient. The derivative of a graph is equal to 0 only in turning points. So g is equal to 0 in two places, when x is negative 90 or when x is positive 90. That's where I have my turning points. My turning point is that x is equal to 90. Another turning point, x is negative 90. Determine the values of x for which f is above g. Which one is f? F is the red one. Ne? When they say f is greater than g, they simply mean when f is above g. Between the point of intersection, you can see that, right? Between the point of intersection, the red graph is above the black one. So I'll simply say when x is between a negative 120 degrees and 60 degrees. Please guys go check lesson number 20. Yes, it's still under paper 1, but graph interpretations are the same. They never change. Just go there and apply the knowledge, guys. So that's how I would have answered the trigonometry questions in the KwaZulu-Natal question paper. Thank you, guys.